It's,
Okay.
that's why I couldn't
Oh,
find
yeah,
it.
I can tell, there you
I'm
go.
like that.
Oh, okay.
Okay.
I
So this course is officially structural materials. You could be taking it under any one of these three numbers, although you're probably not taking it under the undergraduate number. 3371 is the traditional number for those of you in course 2. 2821, and the J means it's joint between mechanical engineering and materials engineering in this case. You probably signed up for blue, and you'll notice that when I edited this thing on Friday, I put navy things that are relevant to you in blue. Right? Yeah, appropriate color for it. Anyway. Coast Guard should be red, is that right?
Orange.
Orange for Russ. Anyway, so I'm the instructor. This course is taught in one form or another every semester, and Dr. Belmar is not teaching during the summer, so it's just me. So that's the intro. This should be up on Stellar. You don't have to take notes. Okay. So why is it not indexing? That's not going to be good. Okay, now it indexes. Okay. The 2N students should also sign up for 2690, which is corrosion and marine engineering, and so they'll probably kind of go together so far as that goes. The corrosion and marine engineering is a 6-unit course. The other, the regular course, 2821, is a 12-unit course, and most of you have no idea what these things mean unless you're an MIT student before. MIT is the only university in the country that I know that does course units. That's my secretary, Jerry Hill, so you can get to know her. She's right across the hall in 4139. That they estimate not only your time in class, but in the lab and outside of class. So a 12-unit course, you're supposed to be spending 12 hours a week on. A 6-unit course, you're supposed to be spending 6 hours a week on. So that's a little bit different than most other things. If those of you that are not 2N students want to take the corrosion course, you can. You should see me about that since it's a 6-unit rather than 12-unit. And we can work out details on that if that is something you're interested in. Administrative details, there's a sign-in sheet going around, and you can contact Jerry, who's just here. The schedule is every day until we complete things. Unless you all have a quiz or something and you wanted to skip class that day, you just need to let me know ahead of time, okay? Ordinarily, I would be lecturing, but I didn't last summer because you're going to see that the Navy students have to take certain things as determined by the Naval Sea Systems Command, and they're already on video, and so we're not going to redo those. Early in the morning, usually 8 to 9 or as arranged. Finish the live lectures in the first half of the semester. The semester ends kind of mid-August or something like that. We will finish the live lectures probably by July 4th, okay? This is the live lecture, but it's just introductory. Student papers or presentations. The student down in DC can do a paper. It's a 10-page paper. And in fact, last semester when I had 56 students, I didn't do presentations because I have to sit through all 56 presentations. And so I switched it over to papers, which is a 10-page paper maximum, and we can talk about that a little bit. But during the summer, I decided to keep the presentations because this is a good way for the 9 or 10 military students to actually talk to each other about what they did, okay, before they came here. For instance, one time when I was doing this, right after the second Gulf War, and I can't remember, there was some capital ship that had to come offline. The war only lasted like 3 days, right? But in the middle of the thing, they lost their 3,000 PSI airline on the ship. I think it was a cruiser, and it was in the Gulf, and they had to pull it back. The admirals weren't happy, nobody was happy. But it turns out, so they did an analysis and they found it was a corrosion problem, it was the wrong type of brass, subject to stress corrosion cracking, which is what happened. And then another naval officer had been in the Naval Supply Depot in Philadelphia, and they were charged with going and finding out how this got into the system. Well, they found 30% of all the valves in the Naval Supply Depot were the wrong alloy. Okay? So, but the two of them probably never would have known that they were both working on different parts of the same problem, one on board ship and one in the supply depot. So you can talk about anything you want in your presentation. Those of you who are, since there's only a small number of 2 SDMs, and you did a presentation last year, so you know what they're about. You can do a presentation if you like, or you can do a 10-page paper if you like. Okay, so we're flexible on that. The thing is, I'd like to get these presentations done during the month of June, and in fact, there you go. Are any people ready this week?
I haven't heard. I told them last week about it, so.
Well, you're all here now. Is anybody ready to do their 10-minute presentation this week? If not, I can just talk corrosion later in the week.
Sure, some of us can be ready.
Okay, well, we'll talk about some other things, but let me know, because we can do about 3 a day. And if I need to know from those of you who are not 2N students, whether you're going to do a presentation or a paper. Okay? The presentations are easier. So we're going to usually meet 8 to 9 in the morning. That doesn't conflict with all these other things in general, right, Cody? We're not running into the math or the SDM stuff? Okay, fine. Student papers present. Most of you are attend 36 lectures. Now, they can be the 36 I'm going to show the 2N students that are required by NAVC. You have no choice. NAVC is inflexible. Okay. The rest of you get to pick from about a dozen modules of 12. So you have to pick 3 modules out of 12. The 2N students should also take this other 6 units. Okay. The theme is flexibility in a stress-free environment. This is mostly for the MIT students. I get usually juniors and seniors. I have had a couple of sophomores. And then I get graduate students. And the graduate students come from almost all the departments in the School of Engineering and the Sloan School and the manufacturing program, which is one of the reasons I teach it early in the morning. A, I'm an early morning person, but B, I run into fewer conflicts then. The key is, I don't believe in the way we educate students, okay? In general, we educate students to take tests, okay? Prepare them to take a test. And I realized this one time 15 or 20 years ago. I get up early in the morning, usually eating breakfast at 5 o'clock. And I'm sitting there eating some cereal at the kitchen table, and one of my children left their high school math book on the table. So I thought, oh, I'll look and see what they're learning. And they had 2 pages on every topic. 2 pages on exponentials, 2 pages on logarithms, 2 pages on differentials, 2 pages on integrals, 2 pages on matrix algebra. I had no idea that math came in 2-page increments, okay? But all they were doing was preparing them to take the SATs, right? And I thought, this is stupid. And then I thought about, well, we do the same thing here. All the students want to do is, you know, what do I have to know for the quiz? Well, you know what? There are no quizzes in this course. You don't have to worry about quizzes. All you have to do is a presentation. And if you get your presentation done in the month of June, then the rest of the thing you have to do is watch the other 36 modules. Okay? So it's stress-free. I told Cody I like the student who said they like to watch the videos while they were fixing dinner. Okay? And you don't have to take a lot of notes, okay? Or you don't have to take any notes. You don't have to do any reading. There is some reading and some of this, so we'll go through it here in a little bit. But the modules they're available. Go to my website, under classes, there's a material selection module that I've lectured 3 times over the last 3 or 4 years. The ones in blue, this is what NAVC says you 2Ed students must take a welding course. And so for years I taught solid state welding and fusion welding, and kind of broke those into 2 12-unit modules. And then when Professor Masabuchi, who was in the ocean engineering department, and then later the course two, the mechanical, when they merged the two, he taught a welding metallurgy course. When he retired, I started teaching a welding metallurgy module. So NAVC says those are your choices. However, you're also a Coast Guard student, right? Okay, so he's decided, and a number of students over the years in the Navy program have decided they wanted to take some other courses, and you can repeat this course, okay? In fact, I've had some undergraduates take it 3 times. So 10% of their entire undergraduate program was listening to me tell stories, okay, without quizzes. Anyway, I teach one on what is engineering, which I ought to do again, but it's basically a lot of things that I think people need to know and try to figure out. The reason I taught it is after having been an engineer here for 40 years, I realized there's not really any agreement around here about what engineering entails. So I kind of taught the course as an experiment to see if I could figure out what's the difference between engineering and science. Codes and standards, I ought to teach this one again. But basically, it talks about measurements, how do you make precise measurements. And I used to talk about the LIGO project, which is at the time it was the largest National Science Foundation project ever. You've now heard a lot about it from last fall. A year ago, I was trying to get Ray Weiss on the phone because I wanted him to come in and lecture. He's kind of the father of LIGO. He's a physics professor. He's 85 or so, and couldn't get him to return my phone call. And we've been friends for 25 years. I helped do some of the management on the welding on LIGO. These interferometric observatories trying to measure 1 part in 10 to the 22nd, most precise measurement in the world. You've heard about it as gravity waves from space now. And the reason Ray couldn't talk to me, he was too busy, they hadn't announced it yet, maybe this was 2 years ago, whatever it was because they had finally gotten one of these gravity waves, but they hadn't announced it yet. Okay, I guess it was 2 years ago. Anyway, so Ray will probably win the Nobel Prize, but I've been trying to get him, I want to contact him and see if he'll come and give a guest lecture. And then it talks about standards. There's lots of standards in the world. It's the boiler pressure vessel code and other standards. And whether standards are good or bad, they really stifle innovation. Okay? You have to follow the standard. You can't do anything different. Did you know that we spend, what, $35 billion a year on medical research, but we still use the same materials from 1972 when they passed the Food and Drug Act? Because any drugs they've been using, or not drugs, but any materials they've been using in the human body, like polylactic acid, which is basically just milk, right? Polymerized. As a plastic, they were grandfathered in. But to qualify a new material, no one can afford it. Not even Johnson & Johnson. No one wants to even try, okay? Because the standards, they're too hard. Okay, they put in standards that are just impossible to meet. So as a result, all the medical people are still using the same materials they were using 40 years ago. Deformation processing, materials processing and casting, material selection and economics, which is a slightly different version than material selection. Those are mine. You can also, Dr. Belmar's taught various versions from his point of view. His undergraduate degrees were mechanical engineering. He got his materials degree, doctoral degree here. And structural life assessment, he's a true structural engineer as far as that goes. And the other modules are, Neil Jenkins was one of my doctoral students working on non-destructive, actually he was working on welding too, I guess. But anyway, he went off and got an MD after that. And so one semester when I was on sabbatical, he came in and taught non-destructive evaluation of the human body. Basically, what does a doctor do when you come in for a checkup? He smells you, he touches you, he listens to you. I mean, he uses his 5 senses to evaluate you, okay? It's a different way of thinking about non-destructive evaluation. And then I had someone who's a graduate of the Sloan School, but a practicing attorney in Boston who he just argued a case in front of the Supreme Court last month. But he loves to teach, and he's come in twice now, actually, I have not updated that. And he's taught law and technology or intellectual property. So a lot of the Sloan students and mechanical engineering students who want to start their own businesses have listened to his 12-unit module about copyrights and patents and trade secrets and things like that. So, sorry you guys, the 2N program, you have no choice, there's no flexibility for you. The rest of it, you can do whatever you like. Okay, any questions? As long as you get 3 of them. And corrosion's not up there, but I think we do have the corrosion lectures somewhere. So you're going to watch 36 lectures, prepare a 1-page outline of each 12-lecture module. Okay, this is not something I started, something Dr. Belmar started. And it turns out I've come to believe that it's a worthwhile thing. And the reason is, you should be able, maybe not this lecture, although you probably could even on this lecture, at the end of the hour say, what were the 2 or 3 things the professor was trying to get across? Because you really cannot get across more than 1 or 2 or 3 ideas in a 1-hour lecture. You can talk about 50 different things, but you can only get across something in terms of a theme that are maybe 2 or 3 things. And actually, I'll tell you the story of how I learned that. And it probably is in, there's a number of handouts you'll have on Stellar. Cody, I think, probably sent this to the 2N students digitally. This is an article I wrote for the MIT faculty newsletter back in 2004 in hopes that Bob Brown would not, who was provost, would not become the president of MIT. And not because of this article, but because Bob is just such a Class A jerk, okay? I'm saying this on videos that will be on YouTube. But he knows I think he's a jerk. He's now president of Boston University because he didn't make it here, which is a good thing. Boston University's losses are gain. Anyway, it's sort of a compilation of about, at that time, what was 37 years of experience as an MIT student and faculty member about what makes MIT unique. And I try to use this course during the summer for the 2N students to help acclimatize you to MIT and the MIT environment, because it's not unique, but it's one of only 2 schools in the country that I know of that only admits 1 class of students, and that's scholars. I mean, Harvard or Princeton or Stanford or whatever will all admit, very freely admit, that they admit 3 classes of students: scholars, athletes, and legacy students. Exactly. What's a legacy student?
Not like my parents, man.
My parents are rich, and so you should let me in. Right? And you can, because at Harvard, there are courses you could take as a freshman and a junior and a senior that are gut courses, and you can gut your way through the whole thing and get up with a Harvard degree. I had a secretary once with Professor Brown. He hired this person that had a PhD in English from Harvard. And he said, oh, they'll be able to help us edit our papers and all this other stuff. Lasted 3 weeks before we fired him. He was absolutely incompetent. He couldn't write a coherent sentence. They had a PhD in English from Harvard, okay? So there are different approaches at different schools, but it turns out only Caltech and MIT are the only 2 schools I know of that will say that they admit only 1 class of students. And everyone else will freely admit they admit people with money, and they admit people who are good athletes and things like that. Anyway, so what happened to me was in my beginning my junior year, I took a course, Introduction to Quantum Mechanics, which was not required. It was in the physics department, and I thought, well, if I'm going to be a material scientist, I should know a little quantum mechanics. Took this course, I had no idea, didn't have a clue what was going on in this course, okay? The teacher was a wonderful teacher. She was the first physics professor at MIT, was female, tenured, full professor. She brought her dog with her, big German Shepherd or something, to class all the time. And she would talk about things, and I read the book, I kept up, but I was getting 15s out of 100 on the homeworks, and class average was 85. And so the night before the final, I figured, well, I'm going to flunk this course. And I decided I'd take the textbook, and I'd just go through and look at the high points, okay, try to figure out the high points. And I did, and I went in the next afternoon, and I finished the 3-hour final in 1 hour and 15 minutes, checked it over for 15 minutes. I had to wait around another half hour because you couldn't leave early. You had to stay there at least 2 hours. And I thought I'd done pretty well. Well, I ended up getting an A in the course, okay? And a light bulb went off, and I thought, oh, it's only the high points you have to understand. It's only the 1 or 2 themes, and all this other stuff is fluff. Okay, so you don't have to know all that garbage. So I actually think it's a good exercise to train yourself to try to, and I quit taking notes at that point for the rest of my career as an undergraduate and graduate student. I would just sit there and try to, I called it guess my lecture, okay? The professor has an outline of what he wanted to talk about, and I was sitting there, I had to guess what his lecture outline was all about. Okay? He talked about everything, but there were only 1 or 2 key points. And if I could get those 1 or 2 key points, I could go into those quizzes cold. Okay? And I did. And I started getting a few keys too. Anyway, nonetheless. You got to prepare a 10-page paper, or the 2 ends, you're going to make a 10-minute presentation. And I know it's early for this presentation, but 10 minutes means no more than 10 PowerPoint slides. And to give you an idea, and I did find some of my others. Here's one that a student did on Liberty ships. Okay, Liberty ships are important to the Navy because the Navy invented fracture mechanics because of the Liberty ship failures. Okay, he led the world at one time. The father of fracture mechanics is George Irwin. He was head of the mechanical engineering department at the Naval Research Laboratory, and he basically invented the field in the late 40s, early 50s. So it can be a topic of your choice, anything you want. This goes for the rest of you, okay, that are not 2N students or Coast Guard students or whatever. You can talk about how Coast Guard ships or old Navy ships that are just completely full thickness rust with paint on the outside. Okay, I've had a presentation on that. You can also talk about the new cutters. You got a new class of ship, but we talk about anything you want. We like to keep it to structural materials, but we've had some things that don't even fit structural materials. So it's a topic of your choice with the idea that if you're interested in it, it will be a better presentation than if it's some topic you're not interested in. And if you have, how many of you had to give a presentation at your last tour of duty before you left? See, you're all ready, as long as it's not classified. You could give that presentation. You may have to boil it down to 10 slides. But if you start back and think about it, you could. There's a lot of fluff in your 40 slides. Okay? So with that, we might try to do some at the end of the week. Okay? And you'll have 10 minutes, and we'll have about 5 or 8 minutes for discussion. So people can ask questions. Okay? So it's not a lot of work, guys, and some of the rest of you, you may have had to do a presentation for some other course. I mean, one student was really interested in the BMW i3, which is a carbon composite vehicle, okay, all electric, and blah, blah, blah. Got a great presentation on that. So anyway, and I gave some topics to Cody so far as that goes. And if you're worried, I guess a lot of you are Navy nukes, and so you think everything in the world is classified that you ever heard in nuke school. And I'll tell you that's not true, but nonetheless, you can't figure out what's not. So you can do the Thresher, you can do, the Falkland Islands War, you can do whatever you want. Those aluminum superstructures really catch fire, and that's still an open debate. But I will tell you that NAVC switched out all their aluminum superstructures and went to waffle membrane steel construction after the Falkland Islands War. So what do you think the Navy thinks? Okay, whether there's aluminum fire or not. But anyway, you should review and watch the other student presentations. It means come to class for the student presentations. That's not hard for you. When I have 56 students, I didn't make them watch them all, but I did it for several semesters where I had 40 or more students. And that's kind of my limit, okay? I can only watch so many. They're interesting presentations, but, I have to be awake for them. Not like coming to class myself. Well, to be public, if you're going to do a paper, we're going to put it online. You're going to have to sign away the rights to MIT. That's not a problem if you're doing a presentation. Although if you'd like to make your presentation available, I'd like to start putting those online. And you can look through some of that stuff too. Student papers, potential topics can be anything you want. You can do iron if you want, or steel, or concrete. By the way, something I just figured out a couple of years ago in my structural class, there are only a few materials that, in fact only 4 materials that are used so extensively that we consume 1 billion tons a year, okay, of these 4 materials. Can anyone guess what those materials are? Concrete?
Steel.
Steel? Well, you took the class before. Okay, they took the 2 easiest ones.
Is water jet?
It's not really a structural material, except in the Arctic, where ice is a structural material, so that probably would account, but that would be a 5th. But it's not exactly something used anywhere in the globe. Number 1, at 53 billion tons, the top winner is called crushed stone. Okay, all the railroad beds, half of your concrete is crushed stone. I mean, okay, so crushed stone, 53 billion tons. Number 2, which one is number 2? I think it's concrete at 2.6 billion tons now a year. Number 3 is engineered wood products, like plywood and laminated wood, 1.8 billion tons. And number 4 is steel at about 1.6 billion tons. And the next, if you took all the plastics in the world, it's 300 million tons. It's 1/5 of the steel, okay? That's all plastics. If you took the next largest metal, it's aluminum at 60 million tons. And so it turns out there's a paper that will be online about an article that I wrote back in 1992, put in the welding, 1991, put in the welding journal, called The Future of Metals, okay? And I wrote this because everyone was talking about fine ceramics and electronic materials and stuff. And I pointed out that back then, steel was about 1 billion tons a year, or 800 million. It's doubled in size in the last 25 years. But steel had an estimated growth rate of 2% per year. Okay? That's not a very big growth rate, but it turns out that growth rate on $500 billion, semiconductors, making silicon and gallium arsenide, is only a $100 billion industry back then, maybe 200 billion now. Had a growth rate of 5%. But it turns out, fine composites, fancy composites, this is something you'll probably see on the videos a number of times. This is part of the X-33 space plane. That was, the whole thing was a failure, but, and you'll get some of that in some of the lectures, but that's a Nomex, which is like Kevlar, honeycomb composite with carbon fiber reinforcement plies as the outside and inside sheath, and it's all adhesively bonded together. And it only costs $12,000 a pound. How about that? Cheap at half the price. Well, expensive at half the price. Anyway, and fine ceramics, which everybody was talking about back 25 years ago, was a $5 billion market with 20% annual growth. And everybody on Wall Street thought, oh, ceramics are everything. You know, they found out that they're brittle. As everybody knows, what's the definition of ductile and brittle? Anybody know?
How much it gives, essentially?
Yeah, before it breaks. So if I have something that's ductile, I can take this piece of plastic, which is polyethylene, and it's pretty ductile. I can bend it in two, back and forth. I can do that all day long. I can take a piece of polymethyl methacrylate, plexiglass, and it's sort of brittle. Okay? Here you pass it around, people can look at the brittle fracture. Can't even show you the fracture in the other one. Okay? That also illustrates another point on that one, point of the stress concentration, where I had a mill the little grooves, the edges. It broke at both those locations. I don't know if you saw that. Okay? Right at the stress concentration in both cases. So some of these principles of mechanics really do apply. So anyway, there's a Future of Metals paper. 97 pounds of every 100 pounds of metal made is steel. Okay? The U.S. Army once spent $1 million doing a study of what would be the material they were going to use 20 years into the future. And they came to the conclusion that it would be steel. Okay? I could have done it for $500,000. I could have given them that report a lot cheaper. And I could have written it in half an hour. Okay? But anyway, that's what some of the stuff on structural materials is about. And there is actually a paper, another paper, that you have on the Stellar website called "Some Materials Research for the 21st Century Defense Needs." It was a National Academy or National Research Council report. And all these people came together. I'm on one right now where they're looking at bolting for undersea blowout preventers in the Gulf. You know, you've all heard of the BP disaster and stuff. Well, it turns out they've had 3 or 4 others in the last 15 years that were near misses. Okay? And they happen to be, in those cases, in most cases, because the bolts failed by brittle fracture, hydrogen, or beryllium, okay, of the steel. And so the Department of Interior, which has responsibility for this and regulating this, formed a committee of about 18 of us or so, and we're supposed to write a report to tell the oil and gas industry how to improve the bolting procedures. So, and actually we had a workshop for 2 days in March down in DC, and I brought in a guy from Rolls-Royce Naval Marine. Anybody ever heard of Rolls-Royce Naval Marine? Yeah, you've heard of it. What are they?
Well, so I was on Freedom in Fort Worth, so they built the MT-30s for the gas turbines for those ships. So.
Right, well, that was Rolls-Royce. Okay, that may be Naval Marine. The one I'm thinking of actually builds the propellers.
Okay.
And back when, probably before all of you were born, in the early 90s, or about the time you were being born, okay, there was a big hoopla because Toshiba sold a milling machine, a 5-axis milling machine to the Soviets, which is the same machine that the U.S. Navy uses to machine every propeller. And it's done right down here in Walpole, Massachusetts. So if you guys could find a day during the summer to go all the way down to Walpole, which is about 40 minutes south here, you could meet with Frank Lanny, who's the chief engineer. He would be very happy to give you a tour. And if you do it properly, he can probably give you a classified tour if you want it. But you don't have to do that classified. It's just an interesting thing, as far as that goes. But they, for their variable pitch propellers, not necessarily very big ships, because I don't know if they have variable pitch on their very big ones, but on smaller ones. The one I worked on was an Israeli Corvette, okay, that threw a blade, and that's not a good day, okay? Sort of like blowing a 3,000 psi airline. And so they've had bolting problems because they bolt the variable pitch blades to the hub. And I can show you a more grip bolt, which is the type of bolt they use. It is much more sophisticated than anything the oil and gas people use in the Gulf, okay? So we could have another $70 billion blowout because they're using good quality galvanized steel bolts as opposed to, currently they use Inconel 718 bolts in critical applications in the aerospace or marine industry, but the oil and gas industry is about 60 years behind the time, okay? So we have the potential of another big blowout coming up. Which, Coast Guard part of the DOI? Yeah. But, you know,
We're Department of Homeland Security,
oh, okay. It used to be part of
Department of Transportation.
transportation, okay, fine. Thank you. Anyway, so I was on this committee for the National Research Council 15 years ago or so, and everybody was so enamored with advanced materials. I was the one saying, well, you're going to use steel, but no one believed me. So I wrote up essentially an outline of my material selection course in about 4 pages. So if you get down to the 1 or 2 themes and you put them all in one thing. So here's a paper that 4 pages you can read that is what I teach in 12 hours. You can expand things to fill the time, right? So you can read that. It's not part of the welding thing per se, but it gives you an idea of why we choose the materials we choose, okay? And I mean, back when I wrote the Future of Metals paper, I used to give the talk and say that it would be 25 years before we would have a low-cost all-aluminum automobile. And by that I meant something like Ford Taurus. And it was about 25 years. And I was predicting that in 1991, and I knew that was true because of the cost of steel compared to the cost of aluminum. So now we got an F-150, which is, you know, a relatively low-cost vehicle. We have all aluminum Audis, but making an all aluminum $90,000 vehicle is no big trick. Okay, we made. I mean, J.P. Morgan, who financed Alcoa in the 1930s, had an all aluminum Duesenberg. Okay, I can show you a picture of it. I got to look at my office. Okay, we could build all aluminum vehicles. We just couldn't build them and sell them for $5 a pound. Okay, or $10 a pound. Anyway, there's a reason for that. So anyway, you can do a presentation or on whatever you want, and we don't have to go through those. Don't be too general or too broad in your presentation. I don't want to know about the strategic importance of aircraft carriers. That's a little broad. Okay, you probably can't cover that in 10 slides. Get down to something specific. One student actually came back from Yokosuka where he had a tour, and they had opened up, and they were going to inspect the seawater tanks on some ship, and they were all corroded. And it was a type of corrosion no one had seen before. People came over from NAVC, David Taylor, the corrosion experts came over. They couldn't tell what it was, and when he left, they still didn't know what it was, but they knew they had to get people in there scraping it, painting it. So they did that. But he had pictures of it, and it wasn't classified, and he showed them to us, and we discussed what we thought it might be. And I think it was probably what's called microbiologically induced corrosion, where bugs start generating acids that eat away your tanks. So, depends on what you put in your tanks. Grading, no quizzes, no tests, no quizzes, no finals. Proposed topic, well, you don't have to do that. There's no issue of collusion in this course. These are some things I'm required to give you. The dean's office says I must tell you what's required. So no quizzes, no finals. There's no problem talking to each other. It's okay. There's no quiz. Okay. Evaluated your completion of 3 one-page outlines of the modules. Some of these other things are not necessarily for the 2Ed students. A lot of students, if you read the evaluation, said they learned a lot from each other's students' papers and presentations. But my philosophy is too much is geared towards taking tests, and so you're not going to be able to show off. And there are, believe me, if you haven't seen it yet, but when you get into the other classes with the regular students during the fall, you'll find a lot of MIT students are macho, and they want to prove to all their classmates how much smarter they are. That's setting yourself up for a big fall, because as I say in my leadership paper, no matter how good you are at something, you're going to find someone at MIT who's better. Okay? One of the things you learn here is humility. It's a fairly stressful environment, but anyway, you may be force-fed humility, but anyway, you learn it. So you wouldn't be here if you didn't know how to take a test. Good teaching makes things simple rather than complex. I tell a lot of things using parables or stories. The students like the stories. In fact, sometimes some of them took me to lunch to hear more stories. Okay, I'm going to do recitations for you, and probably once a week up through July 4th, we'll do a recitation. So I can pass things around, like I brought some Navy things. That's a 2-inch thick electroslag weld titanium. I actually have a full-hour lecture on titanium for marine applications. I worked on the new Alvin submarine, which is all titanium hull. That's an HY-80, that's an old piece of steel from back when we built HY-80, but that was made electric boat. We can talk about other materials. This is a piece of glass armor. Company out here in Western Massachusetts makes all the armor for the President's limo and things like that. And that's 3 pieces of glass with a piece of polycarbonate in between. You can see they're all laminated together, and how you glue them together is important. Okay, joining is important, guys, because otherwise you get bubbles, and you don't want to have bubbles in your windshield. The President's armor is 5 3/4 inches thick on his limo. Okay, it will stop an RPG. Okay. There's not a lot of room in that big limo because it's all taken up with thick doors and things like that, and armor. If you want to talk some about armor, I did serve for about 7 or 8 years on the U.S. Army's review city and for Aberdeen Proving Ground, so I know a little bit about armor technology, most of which I can talk about. Some of which actually I can still talk about that has to do with the improvised explosive devices in Iraq and things. There's some interesting stories there. So keep it simple, and to prove that not everybody keeps it simple, the guy who said keep it simple first, the Earl of Ockham, said in Latin such and such, it is futile to do with more things which can be done with fewer. But they have kept it simple. They've reduced that to keep it simple. And we're not going to just work on things we don't want to. You can study what you want. Get only one or two concepts because everything else is fluff. Numerical results are easier to grade than conceptual expositions. No professor at MIT, except in the humanities department, likes to give something that has a written answer. They like a numerical answer, and it's binary. It's either right or wrong, right? That's because it's easy to grade. Okay? The next question is something I ask students: why would someone spend an entire lecture doing a derivation? You've sat through those classes, not just at MIT, other places, right? So I never understood that. They always make a mistake. They can never get it right. Okay? So why do they do it? Well, my first year on the faculty, I was teaching this course on deformation processing. I'd been traveling for a couple of days. I had an early 9 o'clock class. I came in at 6 a.m. and I had to prepare my lecture. And I looked in the book and there was a derivation. I thought, oh, I'll just do the derivation. And that's when it hit me. Another light went off and I realized you do a derivation because you don't have time to prepare a lecture. Okay? And I promised myself, that was 40-some years ago, I would never do that again. And I never have. If I have a derivation that is not in the book, I will write it out on paper, I will give it to the students. I used to teach thermo, okay, and so there are derivations. And I would hand it out to them and say, okay, now let's talk about what it means. So any professor who gets up and does a derivation and doesn't talk about what it means is just wasting your time. Now, it probably is not good to go tell them that until after the class is over and you've gotten your grade. But nonetheless, there's a lot of fluff out there. And a lot of fuzzy, something I took a course from this guy, Edward Tufta. This is on my small presentation. And he said, fuzzy writing is usually the result of fuzzy thinking. Okay? Well, you're not doing written presentations, but nonetheless, I did give you, or will give you a copy of the cognitive style of PowerPoint. Tufta hates PowerPoint. Tufta was a professor at Yale, and he wrote 4 books on visual display of information, the power of words and things. And he wrote that he hates PowerPoint, and you guys are PowerPoint engineers. You do PowerPoints all the time, so I'm going to give you his cognitive style of PowerPoint. And he tells the story of Lou Gerstner on his first day at IBM as chairman of the corporation. Okay? And he couldn't get in the building because he didn't have an ID yet. So he had to finally had to get some executive vice president to come down and vouch for him, because the security guards wouldn't let him in, because he was only the CEO, right? And then he got into this meeting and he started to get a bunch of PowerPoints from people, and he just got up and he went up and he turned the view graph projector off and says, let's just talk about your business, okay? Rather than filling up the time with PowerPoints, mindless PowerPoints. So he also has the Gettysburg Address. PowerPoint has auto content wizard, and you can put some words into it, and it will give you a set of PowerPoints. And he has the Gettysburg Address of 8 PowerPoints. So you think of what you think of one of the great pieces of American literature turned into PowerPoint. Okay. And the best presenters don't use visual aids at all. You're likely not one of the best. Before we go much further, I do have some more on communications and PowerPoints and stuff. Does anybody have any questions? If not, I'll tell you a story about Lester Thoreau. Well, actually, the first one is I'm handing out a paper on why the World Trade Center collapsed. Okay, I was asked about 3 weeks after the World Trade Center collapsed if I would write an article for a metallurgical journal on why it collapsed. I was so sick of reading stories about how the steel melted in the fire. Anyone who's ever been to a fire scene investigation knows that steel doesn't melt in fire. It doesn't get hot enough. And so I knew that was garbage, but every newspaper article was talking about the fire was so intense that, well, intensity of the fire has nothing to do with it, okay? It's the heat content of the fire and the temperature of the fire are 2 different things. But you can read the article. But what happened is I spent about 3 hours putting this paper together, okay? Some civil engineering professors had a 1-hour seminar. I missed it, but I sent Chris Musso, one of my graduate students, who got permission to videotape it. So I watched their lecture. And then I kind of outlined things for an hour, gathered my thoughts, and then I wrote it for an hour. And that paper became, for 9 years, the #1 hit. If you put on Google WTC collapse, I was the #1 paper, okay? And the reason was, when I wrote it, I knew who I was writing for. I was writing it for a high school senior, okay? A high school science senior, okay? Someone knew some physics and knew some chemistry, and I could talk to him about simple principles, like the difference between heat and temperature, okay? Well, it turns out, since it was written so a layperson could read it, it became very popular. And to me, it was sort of interesting, because I spent less time on that paper than any of several hundred papers I've written before or since. but I got more comments on that paper than all the other papers I've ever written combined, okay? And there are people out there who started whole websites against me because I don't believe in the conspiracy theory. Do you know that 18% of the people in this country believe that the government brought down the World Trade Centers? Originally, it was to get us upset with Israel. It was actually an anti-Semitic sort of thing. And now it's just the government is corrupt. And anyway, so we can talk about that if you want. But anyway, so you need to know your audience. In this case, I was writing for lay people. Or somewhat lay people who may know something about science or technology. So you've got some reading assignments, so the future of metals and the 21st century's research needs and cognitive style PowerPoint. Let's talk about a great communicator. Lester Thoreau became dean of the Sloan School of Management in around 1988. And Lester was a very prolific author. These are some of the books he wrote, one of which became #2 on the New York Times bestseller list. He used to be on the Sunday morning news programs, analyzing things. He called himself an economics educator, but his colleagues called him less than Thoreau, okay? Because he wasn't, a Nobel laureate type economics person. He was explaining things to you. And so I had never heard Lester speak until 1988 when I'm a Sloan grad, by the way. Not a Sloan fellow, but they used to have a senior executive program, which was 13-week intensive program or 9-week intensive program, similar to Harvard's 13-week. And I took the 9-week program. So they consider me alum in terms of asking me for gifts. Okay. Anyway, Lester came and talked to us the first time, and all 50 people were just enamored. And some of these people were CEOs of companies. Others just managers at General Motors. But a manager at General Motors was managing $1 billion factory. Okay? Not a big title, but a lot of responsibility. Anyway, the second time Lester came, I was sitting there analyzing what was he doing that made things so interesting. He would get, at that time, this was late 80s, he would get $30,000 a lecture for going talking to some corporation, the board of directors of the corporation. It's like Hillary Clinton get $250,000 today, right? So Lester was in that ballpark, and I realized the second time I saw him, it's not what you say, it's how you say it. And to give you an example, I learned by listening to Lester that you have to use sound bites and make your sound bites memorable. And since I'm supposed to be talking about welding for you guys, that year, 1988, I was a guest lecturer, gave the keynote lecture at a big welding conference down in Gatlinburg, Tennessee. And I said in my talk, I was talking about resistance spot welding, which is the way you put automobiles together. They put 3,000 spot welds in the average automobile because you need 2,000 good ones. Okay? So that's what I learned from Lester, is how you say it. And a year later, I was at a welding conference at a cocktail party, and behind me I heard someone say, do you know they put 3,000 spot welds in the average automobile because you need 2,000 good ones? Now, how many people would have memorized that if it wasn't said in a memorable way? And to give you another example, later when Lester was dean, he was complaining about Harvard hires away too many of our best faculty, okay, or of our faculty. And everyone knew he was talking, one of the people he's talking about was Robert Merton. Anybody know who Robert Merton is? Well, he was with Black and Scholes. He was the graduate student who worked with Black and Scholes on the Black-Scholes method, which is the method of derivatives. You've heard of derivatives? That's what brought down the international financial markets in 2007. MIT had a piece of that. Okay, we taught the world how to bring down the rest of the world. Anyway, they developed derivatives, and we can talk about the economics of that. But Black and Scholes passed away. Merton was a faculty member, went on to be a faculty member at Sloan. Then he went to Harvard Business School, where he won the Nobel Prize for his work. Okay. But as Lester said in this talk, they hire away some of our best people, but fortunately they tend to hire our extinct volcanoes. Okay? Now the nice thing about extinct volcanoes, you don't have to explain what you mean. Okay? Everybody knows that metaphor, what it means in this case. Okay? So you got to communicate, and this is a little bit of an old slide from last fall, but slogans without content are not communications. And those are, I tell you, I did not vote in the last election. First election I didn't vote in. I could not bring myself to vote. If these were the two best candidates we had out of 300 million people, we're in a sorry state. But anyway, and I can talk about other things in communications about teaching is the most revered profession in Asia, and that's because people like to learn. So why are politicians and attorneys so maligned by society? They spread disinformation and not information. So what you say has got to have some content to it. Keep it simple, and Lester kept it simple, but it was so simple that when you're talking about it, you said, yeah, that makes sense, and people believe it. Now, don't give me PowerPoint slides that look like this, guys. Okay? I just took this one off the web. That's not simple. Okay. So I actually did get through it. Shouldn't have to get through your lecture, but I did get through it. Any questions? And feel free to stop me.
Yeah, so it's kind of administrative for the people who aren't the N2 students. So the in-class lectures, Monday to Friday, does that count towards the 36 lectures you want us to attend? And if
No.
Okay.
No, you don't have to come to class again unless you want to do a presentation. And so we can keep you apprised of when I'm going to be here and when we're going to do presentations. And we'll schedule you in for the presentation. If you want to do a paper, you don't ever have to show up to class again in this class.
But if we prefer to come to class, then that can count towards those 36 that we have to watch?
No, those are
Okay.
recitations.
Okay.
You gotta watch 3 modules, so 12 lectures each.
Okay. I just want to make sure.
And then I will have a recitation tomorrow, unless Cody emails me and says one student's ready to do a 10-minute presentation tomorrow, which I'm happy to let them do. I will probably, you guys want to hear about titanium tomorrow? Titanium submersibles? I got a little presentation on that. So we could do that I could do that in 40 minutes and someone else could do their presentation. Or I can stretch it out, okay? And that'll be the Alvin submarine, it'll be the Soviet subs, it'll be the rebuilding, how Congress took away all the money from the steel subs and gave it to DARPA to kind of come up with the next material of the future for submarines and how that was a big flop, okay? So I mean, it's not just a Navy thing, and the Alvin is a civilian use of titanium submersibles, right? So it should be of interest to a number of people. But I'll plan on doing titanium submersibles as either 40 minutes or the full hour. And if someone wants to do a presentation tomorrow, somebody's got to go first, guys. And some of you already have presentations. So get it out of the way. Then you can sit here. And the rest of the time, just like you get a look at your 36 hours of modules anytime between now and August 15th and write up your little one-page summaries. It just has to be a 2 or 3 line, what are the 2 bullets from lecture 1, 2 or 3 lines on lecture 2, and the whole thing fills up 1 page. What were the themes that you got from each one of those lectures? That way, I know, when I read those things, it's interesting to see how different one student looks at the lectures from another, okay, when I compare them. But I also know that you've watched the lectures. That's so I can tell the bean counter to MIT that I evaluated you. But the rest of you, I mean, so we'll do a class tomorrow. If you got some other lectures later in the week, or I can start later this week giving some of the corrosion lectures, which you're welcome to come to, but they don't really count, okay? And then we will probably take a day a week to do a recitation where I can bring in some touchy-feelies like I did here. I got more touchy-feelies. It's not the same when you watch it on a video than when you get to feel it and touch it and stuff. But the two end guys, if you want, you can watch them over in your room over there, or you can come over here and have breakfast. It's one thing is if you watch it all online, you don't get breakfast. Okay? And Tom's got to worry about the breakfast. Depends on how you do it. I don't have to be here for you guys to have breakfast. Okay? Just enjoy yourselves. Because you won't enjoy some of your other, like the math, physics and stuff. Just make work.
So for the presentations, should we just bring our computer in, or should we just email you the presentation?
You can do either one, okay? The safest thing is either bring your own computer or bring a jump drive, okay? Because you never know what happens with emails and things like that, although my email is working. Oh, I forgot to put this on. So, the introduction lecture, well, hopefully